Hello, and welcome to the Johnson Controls Blue Water webinar for April 2023. I am Craig Hanna, and I am grateful to serve as the engineering manager of the Johnson Controls Water Infrastructure Technology team. Our team of subject matter experts is dedicated to designing, installing, and commissioning projects that reduce water loss, that increase water utility staff efficiency, and that decrease operational and maintenance expenditures. Our team exists solely to provide your water utility with the tools that it needs to run smoothly. I now want to introduce to you two of my teammates, Audrey Noel and Jonathan Gunn. I'll ask Audrey to go first. Audrey, would you please tell us more about yourself and how you help water utilities?
Sure, thank you, Craig. I'm Audrey Noel, Director of the Water Infrastructure Technology team here at Johnson Controls. I have 7 years of industry experience, a Juris Doctorate with an emphasis in environmental law, and decades of experience in operations. I have the privilege of leading the team from the sunny shores of Huntington Beach, but I couldn't do it without our very knowledgeable and talented market manager, Jonathan Gunn, who offices just 2,700 miles left of me in Canandaigua, New York. Jonathan, would you please tell us a bit about your experience, please?
Yeah, is it left or right? I guess it depends if the world is upside down. No, good morning. Thank you, Audrey. Again, Jonathan Gunn. I'm a market manager with the water infrastructure team / engineer. So I have 13 years in the industry, developing products all across the country. And like Craig, and Audrey, I'm heavily involved with the American Water Works Association, including as the current chair of the Customer Metering Practices Committee. And I also co-author a number of manuals, publications, and other documents. So it's great to be here with you this morning. And per usual, I just wanted to mention that we do have all of these webinars. If you've missed a few or you haven't been able to make all of them, we do have all of our content now up on the Johnson Controls YouTube channel, and this webinar should be up. It's usually within a week. It'll be posted as well. So definitely go and check that out. Not only do we have all 16, almost 17 webinars, we also have additional content, videos around performance contracting, around customer interviews, just a number of different things. So if you haven't checked that out already, we'd highly recommend it. We worked very hard to put that together, and we certainly think it's a great resource of information for you. So with that, Craig, I'm going to hand it back to you. And actually, excuse me, I forgot one more announcement. If you will be attending the Oklahoma Rural Water Association annual conference later this week in Tulsa, Oklahoma, we do hope that you'll stop by our booth and meet Craig. He will also be delivering a technical presentation for best practices on large water meter management on Friday morning. So be sure to check that out. I've seen him give that one before. It's a phenomenal presentation. So if you're going to be in Tulsa, definitely go and say hello to Craig. So Craig, you're leaving pretty soon, actually, for Oklahoma. So before you go, do you want to give us an overview of today's webinar?
Well, I'd be glad to do that, Jonathan. And we'll start our webinar today with a short talk about being prepared for the severe weather that often comes when winter gives way to spring. Next, we are so glad to have Devan Shields with us to present his important research into how meter testing methods matter. I believe that Devan's research was one of the most important peer-reviewed articles ever published in journal AWWA about water meter testing, and especially regarding the use of portable water testers for small water meters. Following that, we're very happy to have Gray Anderson from Xylem as our guest today. Gray, who is the product manager for the R&I and NCS product line for Xylem, will be providing us with an update on all things new with the Sensus FlexNet AMI System network. And having been born and raised on the north side of Dallas, which means I have seen some severe weather events in my life. Some winters, we would lose power for between 1 and 3 days because of an ice storm. The weight of the ice building up on the power lines was simply more than the lines could withstand. And then there was the weight of the ice on the tree limbs that would cause them to break off and take the power lines with them. And during the spring, tornado watches and warnings, along with severe hailstorms, are just a part of life in North Texas. And thankfully, I've only seen tornadoes from a distance. I really want to keep it that way, but there have been a few times that I truly wondered if one was about to form very near me. And I can well remember a couple of times that we spent most all day in the hallway at school preparing to duck and cover at any moment. So Audrey, would you please remind us of how we need to be prepared for a severe weather event?
I'd be glad to, Craig. Having spent much time in Kansas, Missouri, and Oklahoma, I can say that I've seen my share of severe storms too. We want to remind you to make certain that everyone knows of at least 2 ways to exit both their rooms in the residence or their offices. This is important to know in case of a fire, tornado, or active shooter situation. If you have children at home, it's a good idea to choose a designated meeting place outside the home and to practice using those escape routes so they'll be prepared for an actual emergency. If you live or work in a multi-story building, it's a good idea to purchase a foldable escape ladder in case the path to the stairwell nearest you is blocked. You can purchase these ladders at home improvement stores or online, and they come in both 2-story and 3-story lengths. If a severe weather event is forecast, it may be a good idea to drive to the gas station, fill up the tank of your primary vehicle. On the day of the event, monitor both your smartphone and a radio that's tuned to a local station for alerts and updates. Before the storm arrives, make sure you have a battery-powered radio, flashlights, and battery-powered lanterns, extra batteries, and those handy charging blocks for your cell phones. If you must evacuate the area, such as for a hurricane, unplug everything but the refrigerator and the freezer. And depending on the severity of the storm, you may consider turning off the water, electricity, and natural gas service to the building. Lock the building before leaving the area and choose a point of contact who lives in an unaffected area so that someone knows to where you're evacuating and how to relay messages to you. Always follow the recommended evacuation routes because those shortcuts may be blocked off.
Well, Audrey, you and Jonathan will laugh at this, but our family didn't have a battery-powered radio until I was in high school. So whenever our power went out, I would grab my trusty Radio Shack 75-in-1 electronic project kit that I got for Christmas, and it was either 77 or 78, and then build a crystal diode AM radio so that at least I would have something to listen to while I sat there in the dark. And I think, Audrey, you had one of those too, didn't you?
I sure did, Greg.
Yeah. Well, our boss, Philip, laughs about this, but there is a run at the grocery store every time a major storm is forecast in our area. Everyone here stocks up on canned goods, bread, milk, and bottled water. And I think that's because where I live in West Texas, a severe storm event can cripple our city for days. For example, in 2015, Winter Storm Goliath dumped over a foot of snow in one day with very high winds that created substantial drifts. And our town was mostly impassable for the next 4 days. Now, while a foot of snow in one day is nothing for Jonathan, our town was simply not equipped for a snowstorm like that. And then there was Winter Storm Uri, which probably no one will ever forget that lives in Texas, because ERCOT, our power provider, had a blackout across most of the state in February of 2021 when we didn't have power for many days and some places for over a week during freezing weather. So it's a very good idea to have at least 1 week's worth of food supplies and plenty of water for every person in your family before a major storm like that approaches. And don't forget to keep a hand-operated can opener in your house. Otherwise, those canned foods won't be of much use to you. And I can tell you that after Winter Storm Uri ended and the power was restored across Texas, I bought a 2-burner camping stove and several small propane bottles that I keep in storage just so that we can both cook and boil water the next time that the power goes out. And in a pinch, a few drops of iodine can be used to purify water for drinking, and it's a good idea to have a small water purifier on hand. And Jonathan, what are some other things that we should consider when preparing for severe weather events?
Yeah, so Craig, we usually prepare for the heat up here, not the snow, right? Just kidding. Don't forget about the needs of your pets either. Your family is first. Pets are usually part of that, so don't forget about them. Keep a good first aid kit ready and have plenty of blankets. It's a good idea to stock up on medicines that you may need, along with basic toiletries to maybe last a week. I think that we all learned that lesson the hard way during the first few months of the pandemic, when we all struggled to find various paper products, toilet paper, paper towels, hand soap, cleaning supplies, things like that. If severe storms are expected in your area, it's a good idea to have a tool bag ready with the basic hand tools as well, and also to stock up on tarps, tape, rope, and other repair supplies. And I'll just close by saying that one of those portable phone or laptop chargers or a car jump starter with an AC outlet is also a great investment. I know I have one. I've used it many times. Usually you can find some that are all in one, where you have USB ports on your car charger. I mean, all sorts of things you can get. I carry one in my truck. Like I said, I've had to use it several times to help both myself and family members, and even strangers who are stranded because of a dead battery. So with all the devices in our labs that require power, it's always nice to make sure you have some sort of backup to keep those devices working. So with that, Craig, I'm going to hand it back to you to introduce our guest today.
All right. Well, thank you, Jonathan. And yeah, you're right. I've had to use my device like that so many times to help people with dead batteries. It's one of the best investments I've ever made. Well, I am so happy that Devan Shields could join us today. And since Devan will be discussing how water meter testing methods matter, I must share with everyone one of my absolutely favorite photographs. I won't tell you where I took the photograph, but I can tell you that this water meter test bench is located at a very large water utility in the Deep South. The plastic bag, the athletic tape, and the purple towel draped over the pipes are strategically placed to keep water from spraying the operator during a test. Water meter bench testing is a closed loop process, and the holes in the pipe and the openings in the fittings on this test bench simply mean that the test results will be invalid from the start. And so I would now like to introduce to you Mr. Devan Shields, who is a project engineer at Sunrise Engineering. Devan develops water and wastewater infrastructure solutions, including master plans, designs, and facility evaluations. He has worked in research, analysis, and design for cities and districts, primarily in Texas, Arizona, and Utah. And Devan has authored several publications on water meter performance and evaluation that involve coordinating with utilities across the country. And now I'm going to turn the presentation over to Devan. And Devan, if you will talk to us about your research into water meter testing.
Sure. Thanks, Craig. I appreciate you giving me a chance to talk on this and see if I can get these slides to pull up. How's that?
There we go.
Looks good.
Hey, great. We'll go from there. Yeah. Craig, thanks. It is a pleasure to have a chance to talk about this project. You were a big help in taking it from an idea to some data and into an article that we're able to reach a lot of people with. So thanks for this opportunity, and thanks for your help with making something out of this.
Well, you're quite welcome.
It was fun to get into it and find out what we found out through the process. I first got the chance to work with Craig as I was doing research at the Utah Water Research Laboratory, which is a really unique facility in northern Utah, and it's presented all sorts of unique opportunities for all kinds of research on anything that has to do with water, including a lot of water meters and some great testing setups. We're able to look at a lot of different things that were pretty neat. From the exposure that I'd had there on several previous projects and a lot of meter testing that we had done, we came up with the concept of looking at how utilities were meter testing. And we got enough momentum to get a study off the ground, and we're able to look into some aspects of that a little further. I wanted to start off with talking a little bit through the background of why we thought this would be interesting to take a look at. In other projects, we had tested all kinds and sizes of meters and a whole lot of different setups. One of the more interesting types of meters in these tests was a fluidic oscillator meter that used the Coanda effect and were marketed as the first solid state meters. That's probably 15, 20 years ago now. They were totally electronic with no moving parts. So we had seen some interesting results in the other projects that we'd worked with these. So we wanted to take a look at those solid state meters and look at how different testing methods affected them. Since there wasn't really any other info out there on these like there was for the other meter types, that it was new and different, and we wanted to take a closer look at that. We also wanted to look at the variances that existed out in the real world on test benches that utilities were using, like that first one that Craig showed. Those are some variances that change results. And then also to see if there were any common sources of error that we could highlight, ways that we could point out common pitfalls that utilities might run into when testing meters. We could highlight and suggest improvements on. So our research approach with this, we put together sets of 10 meters. They were all 5/8 by 3/4 inch meters, and then we had 2 each of 5 different meter types. So kind of like a Noah's Ark scenario there, where we had a couple different piston meters, nutating discs, single jets, multi-jets, and the fluidic oscillators. We wanted to be able to pick up on any sensitivities different types would have to different test setups. So we would test each of them at the water lab there, and then we also coordinated and shipped them to 12 different very helpful water systems across the US. We had a couple different sets of these meters, and so we test them at the water lab, send them off, and then get them back and test them again, and send them to the next one, and so on until we had our results from both before and after each water system for each meter. We asked each of the systems to run the tests at the same flow rates, the AWWA M6 manuals, low, intermediate, and high flow rates. We wanted them to use their typical procedures. We didn't give them instructions on doing anything special with these, because that's really what we wanted to see is how utilities were testing meters at their benches. And then report test results along with a description of the process, like how many they did at once, the order they tested them in, or the sequence, the space between each meter, what they used for flow control, and pictures for each of those setups.
And now, Devan, were these new meters or were these meters that had been in service for some period of time?
They were all new meters.
All new meters, okay.
Yeah, so there were other projects where we looked at meters that had been pulled from service and had some interesting things there, but where we wanted to look at the effects of meter testing itself, we wanted to have these meters be as consistent as possible, and so we used all new meters for these. The low flow test results showed the largest variation between the utilities and the water lab results. So this green are the averages between the before and after tests for each of these utilities. As we shipped them to different ones, the yellow bars here are the utility test results. Now this is scaled from 80 to 105, so it's not like this is 0 or anything. But so this shows the average between the utility test results and the water lab test results for all 10 meters, so not looking at any specific meters, just the average for all of them in the group. So most of them were pretty close. There were some larger variations in utilities number 2, 5, 9, and then 10, 11, 12 all had some interesting things there as well. With the intermediate flow tests, they correlate a lot closer to each other and to the water lab results, as was expected. On that same scale from 80 to 105, this chart kind of shows that there's a lot less variation with those, with all except for number 12 here. And then the high flow results at 15 gallons per minute were similar to those intermediate, where most of them are much closer even than the intermediate results. The one outlier from these sets is this utility 12. This was the only utility involved in the study that used a portable master test meter and tested the meters individually. So most of the utilities used volumetric tanks, similar to the setup that we had in that first photo, and hopefully with fewer closed loop issues than the photo that Craig showed. We also didn't have any guarantees there, so that could have been something that affected some of these results. But we did want to point out that with the portable test meter, that they were significantly different than the rest of the benches that were used in testing. So we had also noticed differences in average test results by meter type, which was particularly interesting. So aside from that utility 12, that utility 12 data was excluded in this figure because it was so different from the others. As far as we could tell from the pictures and descriptions that we got from the utilities on their test setups, each of them followed the recommendations of the M6 manual, but the average differences in the test results for the fluidic oscillator meters at low flow rates were huge compared to all the other ones. So this shows those average differences by meter type for pistons, single jets. The fluidic oscillators is this one that's up over 30%. And then the mutating discs here. The mid-range or the intermediate and the high flow are smaller differences for each of those. But those low flow tests for the fluidic oscillators were much larger than the other meter types tested. We were a little surprised that this mutating disc meter showed a high variation in the low flow rate. We dug into that a little bit further and found that it was likely due to one test result from a utility where the accuracy was reported for 1 meter at 20%. So without that, I think the average for the low flow rate for those mutating discs was about 2%. So it was on par with the other meter types except for the fluidic oscillators tested there. So because none of the other results for that meter were anywhere close to the result, we figured it was likely an error of some kind. Hard to say what exactly, between reading or recording, an obstruction in the meter, trapped air, or something like that. The piston meters showed the lowest variation between the tests at the water lab and the utilities, indicating that they had the least sensitivity to the different test setup factors like meter sequence, space between meters, and the system pressure. So because of that, we ran some analyses just based on the piston meter results to use as kind of an indicator of other test practices that we might be able to see some or gain some insight on from those. So these charts show the results for a single piston meter tested at each of the utilities. So this first group all tested the same set of meters, and this second group was a second set of meters. So these results are all for the same meter, the piston number 1, and these were all for the same meter for piston number 2. So most of the results on these were fairly close. This one's for the low flow. There were 5 that were less than a 1.5% difference between utility and water lab results, and 3 more that were within 2% of the water lab results. So again, it's hard to pinpoint what causes larger errors for like utilities 3 and 7 that were kind of outside that range. But possible factors include low flow rate or flow rate variation. It's tough to maintain those steady low flow rates. Poor meter installation, register reading errors, trapped air in the system, or insufficient test volume, or leaks in the test bench plumbing, like we have heard. For those same meters at the intermediate flow rates, as expected, they were closer than the low flow rates, but we did have one outlier here in utility number 3. In this case, the likely culprit is an insufficient test volume, where they ran this test at 2 gallons per minute for 1 gallon of volume. So they ran the test for 30 seconds. With such a short test, the amplitude of errors caused by the small variations magnified for things like the gearing and the reading precision. Another thing to keep in mind is just that the measurement resolution in a volumetric tank needs to be taken into consideration when setting up these tests. And so a small reading error with a small volume can translate into a lot larger error in the accuracy testing. For the max flow rate test, the 15 gallons per minute, they were closer with all utilities using a sufficient test volume for these. All but 3 of these tests were within 0.5% of the water lab results. So they were a lot closer. Looking at a similar analysis for a single fluidic oscillator from each of the test results, with the other meter types, like we had mentioned before, the utility test results were pretty close to the water lab results. Looking at the low flow results for the single fluidic oscillator meter that we tested highlights the sensitivity of these meters as the largest factor in the variations for the utilities 2, 5, 9, and 10 that we saw in this first chart. So without those fluidic oscillator results, these results were a lot closer, which kind of showed that overall the results weren't as different as they looked like in that exhibit. So with the consistent results of the water lab test results and the wide variation utility test results throughout the study for these fluidic oscillators, it's evident that the differences in the test results are due to something other than the meter accuracy. So the water lab test results were really consistent for these fluidic oscillator meters throughout the whole process, and then they're just jumping all over the board with each utility based on test setups. And this one's also from 0 to 100, so a lot of these, like number 5 came in at 20%, number 10 was next to 0. So the testing setups had a huge impact on the accuracies recorded for those. This figure shows results from a follow-up test that we did after receiving all the results and running through some of these analyses. So at the water lab, we tested several different test bench setups to illustrate effects of those different setups on the fluidic oscillator meters at the low flow rate. So we looked a lot closer at how the system pressure and the flow disturbances caused by upstream meters. Now, I mean, there's a lot of different variations that are possible in test bench setups, but those are the two that we wanted to focus on for these follow-up tests. So we looked at this, testing the fluidic oscillator meter at 95 PSI alone, which those results were a little lower. So most of these for the low flow rate were over 100%, which these were all at a lower pressure. At 95 PSI, we came in close to 95% accuracy. So the pressure itself did show some impact. The next one was 10 PSI at 8 inches after a piston. So we had a piston meter upstream with an 8-inch spool piece or separator between them, and then ran the test at 10 PSI, and the results improved slightly from when we were on the 95 PSI alone. The third one was 95 PSI, 1 inch after a single jet. We ran it with a single jet, assuming the single jet to be the meter that caused the least flow disturbance of the other meter types that we had tested. And this was consistent with what we had thought. It did impact the accuracy some, so it dropped down in the below 80% for this one. And those results were pretty similar for running the test 95 PSI, 8 inches after the piston. So the only difference between this purple column and the blue is this one's at 10 PSI, 8 inches after a piston. This one's at 95 PSI, so at the higher pressure, 8 inches after the piston. And then the worst results that we saw were at the high pressure, just 1 inch downstream of piston meter, where we got below 50% with Hallam. So yeah, that was an interesting follow-up analysis that we did that kind of highlighted those specific items that impacted the test results for these fluidic oscillator meters. So the conclusions I wanted to just run through that we highlighted in the article through the study was the first big recommendation that we had was stick to the code. We watched Pirates of the Caribbean with my kids the other day, and that was the thing with the pirates is you stick to the code. The recommendations from the AWWA M6 manual are valuable. There's been a lot of work and research gone into those that can provide utilities with consistent results. And it's something great that we have to point to for background and reasons why that we do a lot of things with those tests. Another conclusion that we came out with was that those piston meters are the least sensitive test setup. Not to draw any inferences on how that translates to meter accuracy in practice. We didn't make that stretch in this research. It was pretty limited to test setups and their impacts on results. But of those types that we tested, those piston meters were the least sensitive to the test setup. The third one I wanted to point out was to crank it up to 11. Talk about volume. Don't just go to 10, crank it up to 11. That was probably the most common thing that we saw with as far as an error in test processes with the different utilities is that using a volume too small magnified those errors that came from different factors, but increasing that volume decreases the likelihood of larger errors from small problems. Another big one that Craig had mentioned early on as well with this is that the test benches were very superior to the portable master test meter for accuracy. But the results for each of those were really not comparable between the benches and the portable master test meter. And the last one, that suggestion, I guess, is just to understand the measurement principles for the meters that you're using or the meters that you're testing. To understand what small variations might have an impact, and know what we can do to mitigate those potential issues. With that, want to take any questions we've got, or any that come in over the chat.
Yeah, Devin, I was wondering if you could comment on making certain that your test bench is in good working order, and then if you could also maybe talk about training and qualifications for the person that's actually conducting the test.
Sure. Yeah, I mean, obviously with that picture you showed, Craig, the having water leaking out in between meters, you know, it's hard to quantify because it's spraying. Well, how much is that spray? Is it an eighth a gallon a minute? Is it more or less? But it throws that uncertainty way up. Another thing that we saw, and that is a recommendation in the M6 manual, is that sometimes if we're using excessive pressure, particularly on meters that have plastic bodies, you can distort the measuring chamber and cause problems with that as well. But having things clean to the extent it's practical, you know, we're not going to perform surgery on any of these test benches, but those kinds of things make a huge difference. As far as the training and qualifications, I think the important things are to make sure that whoever's running those tests understands what kinds of things will impact actually those tests. Like if you've got a 100-gallon tank that you're using and you're trying to accurately run 1 gallon and measure that, it's not going to work. That's the instance where the precision on the measurement equipment, if you understand that, you know, a fraction of an inch is 20 or 30% of your measurement volume, that's a problem.
Mm-hmm.
So using the right equipment and just understanding what the important factors are in those. There are a lot of great resources out there with the M6 manual in particular, and other things that you can look at and point to understand what's important in these. What are some other things you've seen, Craig, in working with utilities and their test benches?
Well, the main thing is I've seen some really nasty test benches that basically serve as tool holders and plotted plant holders and everything else. And we do have a question in the chat room, and I know your research didn't apply to this, but hopefully you've maybe kept in communication with Michael Johnson and Steve Barfus at Utah State. But the question is, have you tested residential ultrasonic or electromagnetic meters and compared them to other metering technologies? And if so, what were the results? And then there's another did the utilities follow the test setup or the M6 manual according to when they did the testing?
Yeah, so the biggest project that I'm aware of, where we looked at the ultrasonic and electromagnetic meter accuracy, not necessarily with test bench processes, but with the comparable accuracy of those meters themselves, was that ongoing study that I had some involvement, particularly early on with you, Craig, of having those meters in tandem, and which we saw mostly comparable results with those. I would expect that the test bench results for those meters, the electromagnetic and ultrasonic solid state meters that are being used more and more now, would be comparable to the like the piston meters that we've had, and the disc meters and others that we've had with them in tandem.
All right, well, Devan, thank you so much. And now, Jonathan, would you like to introduce Gray Anderson?
Yeah, absolutely. And I'll mention too, for anybody that's having issues potentially with the handouts, you know, the email, as you know, if you've been with us for a while, is bluewater@jci.com. We're happy to send it to you that way as well. So thank you again, Devan. Great information. But yeah, no, I'd like to welcome Gray Anderson, who's a product manager for the R&I and NCS product line with the Sensus FlexNet AMI system, to the webinar today. Gray, welcome. Thank you for being here. Would you mind telling us a bit more about yourself? You know, how long you've been in the industry and kind of all that great stuff?
Yeah, absolutely. And thanks, Jonathan. My name's Gray. I'm a product manager for our core AMI software solutions at Sensus. So what that means is our R&I and NCS. My passion is working with customers to understand their processes and their pain points so that we can tailor our solutions and build our solutions to meet those needs and bring you the most value. So I joined Sensus only a year and a half ago, which is pretty young, and in the time a lot of our folks at Sensus have been there. But I got a lot of experience in the software solution space, but did not come to Sensus from the AMI smart metering world. So I think over the past year plus, I've learned a lot about smart metering, and keep learning from people like you all on what it takes to deliver products that solve these unique problems that utilities are facing. So again, I learned the most from working with utilities and experiencing those unique challenges that they're facing every day. And then the goal is to build out those software solutions accordingly. So, I'm a mechanical engineering degree from NC State. I was born and raised in North Carolina. I'm from a small town called Pinehurst that maybe you're familiar with if you're into golf. We host the US Open maybe once every 7 or 8 years. And a fun fact about myself, I actually had the opportunity to play golf with John Daly 9 holes several years ago. So, and that was quite an experience, as you might expect. So,
who won?
Yeah. What was that?
Who won?
Let's just say not me. Anyways, it was fun nonetheless. Yep. So the agenda today, I'm going to be getting into an overview of our communication infrastructure, FlexNet. Then we'll get into some of the products we have to drive value outside of just metering, and then finish with the software solutions that we have to help capitalize that beyond metering value. So on this slide today, and Craig, are you able to give me control to click your screen?
I can try. Okay, you can try. You should have it now.
All right, it's asking me to show my screen, but let me see if I can figure this out. If you give me one.
Okay.
Are you still seeing the presenter mode?
What we really need is an 11-year-old to come in here and show us all about technology.
Yes.
All right.
Yeah, For some reason, it's not allowing me to put the.
Okay.
Let's see. Can I change which screen I'm presenting on?
Yep. So I think if you go display settings,
Let's see.
Yep.
Where's that, Jonathan?
So it's up near the top there. It should allow you to swap presenter view and slideshow. So whatever screen the actual slide is on, it should switch that for you.
And sorry, where is that? I'm not seeing that.
It's
up
not
near
on the
the top.
console. Yeah, it's right above. It's right above. It's in the black bar on the very top of your. It says show
Yep.
taskbar display settings.
Yep.
It's not on the console on go to webinar. It's more on your PowerPoint.
Correct. It's not, yeah, I apologize. It's on PowerPoint. Yep.
Oh, okay.
And if you do that, it should say swap.
There we
So
go.
it should do that for you. There you go.
Okay.
Are you now able to see that okay?
Absolutely.
Yes.
Great. Okay. Sorry for the technical difficulties. Being the software guy, it's a bit embarrassing. So we'll keep moving along.
Not your software. It's not your software.
Right.
That's right. So what is FlexNet? FlexNet is our advanced metering infrastructure that operates on a dedicated spectrum to strictly control two-way communication to meters. We'll get into what I mean by dedicated spectrum on the next slide. But FlexNet is made up of three major components. The first is smart points, so which are RF communication devices added to or integrated with a meter. And these are broadcasting meter data and receiving remote commands from our RNI. The next component is your base stations. So base stations are your data collectors that receive data from meters and smart points and can be installed inside or outside. So whether that be a ground cabinet or a service pole or other existing infrastructure that you might have, such as a water tower, we can install that base station anywhere. And then the third component is our RNI, or regional network interface, which is the interface that processes and stores the various FlexNet data and delivers it to other applications such as your MDM, Sensus Analytics, pressure profile, which we will talk about, utility data lake, which is another application we'll talk about. But that's three major components of FlexNet and how it works. The RNI is used to manage that communication with these FlexNet devices. It provides you the tools to maintain the AMI metering assets remotely, so you can keep data flowing to these critical applications and really reduce the amount of truck rolls that you have to a service location to investigate a particular issue, because you can do it remotely from the RNI interface. So what I meant by a dedicated spectrum, FlexNet operates on a dedicated spectrum with an FCC primary use license to strictly control network traffic. With a dedicated spectrum, interference and noise is greatly reduced. So all the traffic is dedicated to FlexNet operations. So in this image, you'll see on the right is your public frequencies where there's a lot of traffic, there's a lot of noise, and a lot higher chance for collisions. Whereas FlexNet falls under this dedicated spectrum on the left where there's a lot less traffic. It allows you to travel much more quickly, safely, and reliably. So here's another example of, it's a hometown example, as I'm from Raleigh, North Carolina, of what public spectrum would look like. Lots of noise, hard to communicate, a lot more risk for communication errors, and taking a lot more time to communicate. Also, the Hurricanes are in the playoffs, so go Canes. And this stadium is what the Carolina Hurricanes looked like 10 years ago when we were the worst in the league. So No noise, much more easy to communicate. This is what FlexNet would be. Easy to communicate quickly and securely. So to touch a little bit more on the benefits of FlexNet, FlexNet again uses a FCC primary use license for 20 years. That is utility owned, so you own the network. This means that no one else can use that spectrum, as we talked about before, so all that traffic is dedicated to FlexNet operations. Our products have industry-leading warranties on network performance and product lifetime. We actually put these warranties into our contracts with liquidated damages attached, so it can give you the confidence that we will back them up and that we believe in these warranties. The overall cost of a FlexNet network compared to cellular is lower because we are a purpose-built AMI system that allows us to better control that cost. We also offer 100% managed services for your FlexNet network. We call this our network as a service, or NAS model. And this is where Sensus owns all of the infrastructure, and the utilities just pay Sensus monthly. This model is made even better if the utility owns the assets where we hang those base stations. So as I mentioned before, whether it be a water tower, a building, a service pole, if we can hang base stations in those areas, we pass that saving along to the utility to reduce that cost even more. So reliability, our technology can be depended on to gather data from not just the typical AMI devices, but any device communicating over FlexNet. We will get into the smart gateways in a little bit, but overall, this keeps your data safe, and our managed services team is also ISO certified. Our managed services team ensures every system along the way is secure with industry standard and proven security schemes and algorithms. We have automatic failover and backup in our data system center, so your system remains up. And again, we back this up with our contracts as well. Redundancy, every point in the network has multiple redundancies built in. So redundancy is key with FlexNet. There is not a single point of failure. We have a point to multi-point system where each meter is heard by multiple base stations. So if one base station is not hearing a message from a meter, another one still can hear that message, so that your data can reliably and consistently be transmitted on time. We believe redundancy really builds out the reliability of our network. So each base station is specifically tuned for the best performance, and this is an industry-leading performance. And again, I keep saying this, but we guarantee that performance with a service level agreement for our network as a service customers. Resiliency, our devices pass the test of time and are guaranteed. Our meters and smart points are designed and engineered to last for the entire life. We have an industry-leading warranty where what I want to point out is we have a resetting warranty, meaning if you have to get a new device under warranty, that warranty actually resets for the full 15 years plus 5 years prorated. Now I'm going to move a little fast because I am conscious of the time here. So now that we've covered what FlexNet is, I want to get into ways you can utilize FlexNet beyond just metering applications. So FlexNet is not intended to replace SCADA in any circumstances, but rather can be a supplement to the current system you have in place. So the advantage of FlexNet is the ability to deliver valuable data with battery-powered devices where there may not be any power. Utilities often have monitoring of assets through SCADA at the most critical locations, but have not been able to justify the capital expense at less critical but still important places along the way. So using a FlexNet-enabled device, monitoring can be achieved at these locations for a relatively low cost, since the infrastructure is already there for the communication. And that's with the use of a smart gateway, which I'll touch on here in a minute. These devices devices that are typically required hard connections or costly cellular connections to FlexNet, this provides a low cost and low powered alternative to that. So we give you the ability to monitor and provide visibility into physical infrastructure where SCADA is not necessarily financially feasible. Some examples of what that might be: monitoring pressure throughout your distribution network, monitoring level at a critical tank or lift station, monitoring inlet and outlet pressures at a pump station, monitoring flow at a flow control valve, so forth and so on. There's a lot of applications where we can use FlexNet to transmit this information and use it in a valuable way to maintain our distribution network. So to get into a couple of the products used to transmit this beyond metering data, the ALI smart water meter. This has a lot of features packed into its form factor here. It's got an integrated shutoff valve, but it also has pressure and temperature sensors in addition to its core metering capabilities. So this meter will check pressure every minute and compare it to preset alarm thresholds. Once an hour, a smart point radio will get the latest readings from this meter and send that across FlexNet. Those alarm thresholds and durations are adjustable over the air remotely, so you can customize those to be at the whatever thresholds make sense for your utility. And then Smart Gateway, which I mentioned several times, is essentially our Swiss Army knife for monitoring applications. It can power and read sensors with variable measurement and transmit settings. A common setting is 5 minutes of sampling with a 15-minute transmit rate, but that is customizable to meet whatever that business need is. The Smart Gateway is great for connecting sensors in areas where there is no power or where running power would be cost prohibitive, and you want a plug and play monitoring solution. So this could be a pump station, a PRV, really any access point on your network. It's intrinsically safe, Class 1 Div 2 certified, and as I mentioned previously, unlocks the ability and flexibility to expand your monitoring capabilities to further maximize this FlexNet system. And Craig, I see that we're at time, so I want to be cognizant of that.
Yeah, is there anything else you would like to cover very quickly, Gray?
I would say, you know, so this is being recorded, so I would say let's keep going, and then you know, if folks have to drop, you know, we apologize for running over, but this will be recorded, will be put on the YouTube channel. By being here, it means you're registered, so you'll be getting a link as well to go to webinar recordings. So you know, in my opinion, I say let's keep going.
Okay,
sounds
great.
good.
Thank you. So moving on, so we talked about some of the hardware products to give us that extended monitoring data. I wanted to touch on a couple of the software solutions we have at Sensus that take advantage of that data. So one is Pressure Profile. So what is Pressure Profile? It's the software that makes all the pressure data from these smart meters like the ALI meter and from the sensors connected to smart gateways visible in a graph and in chart format. So it helps our utility customers make informed operational decisions, improve customer service by having the right data at your fingertips, helps you tackle non-revenue water through pressure management, and improve modeling by using more granular data. So this slide has quite a bit to take in here. I know I'm throwing a lot at you, but this here is an overview of what that application looks like. So the main page of this application sits on an Esri map with pressure sensors appearing as these various icons. So there's two types of icons, sites and sensors. Sites are distinguished key assets and can be viewed on this map exclusively and filtering out all the other sensors. Sensors could be, again, these ALI meters, or it could be smart gateways along the way. When sensors are selected, an information panel is going to pop up and show the plot data in a table with the sensor's name, which is on your right side here. Utilities get to give each one of these sensors a name and an import file. which helps make them easily identifiable. And the cool thing here, and I can't take credit for this, one of our product managers, Joe Dreyer, really helped design out this solution. We also support the GIS integration here. So utilities can sign into their ArcGIS online account from within this application, and it will overlay 2 layers for showing the water lines and pressure zones. So you see the pressure zones here, and then the water lines throughout the map. There's also an address search widget in the upper left corner, which helps you zone in on maybe a particular customer complaint or problem to see, do I have any pressure issues in that area? So you'll see they're all colored differently. On the bottom here, there is a legend showing what those colors mean. If it's yellow, they're low pressure. If it's red, it's high pressure, and really blue is more your sweet spot. And that all is customizable again for what your pressure zones should be. So this is just one example of an application we have that takes advantage of that FlexNet data that goes beyond just metering. Another example, and this will be my last example, is Utility Data Lake. So Utility Data Lake is a product that we offer at Sensus that is a predefined central place for FlexNet data to reside. It puts the data at your fingertips that you can use to create custom reporting. You can use the built-in superset functionality, or you can use your own BI tools for custom reporting purposes. So for some of the benefits, Utility Data Lake provides you all the data from your FlexNet devices. It allows you to build your own custom scripts and reports tailored to your specific needs. It stores 3 years of data for long-range data analysis, which is going to eliminate the need for any expensive hardware requirements for extended data storage on your side. It provides a consistent data schema, which I think is important to point out. So when you take an R&I upgrade, the data schema remains the same on UDL, so you can be sure and confident that your custom reporting won't break when you take new R&I upgrades. It's completely independent of your R&I. What I will say is there are endless possibilities for Utility Data Lake, as it provides the flexibility and the data to quickly create your own valuable insights that you might want access to. I think that I love hearing from various utilities on what they'll use Utility Data Lake for, things that we haven't even thought of, but again, that data is right there at your fingertips. So just one use case I'll point out, stormwater data can be gathered from sensors and smart gateways. This data can then be used to support basin modeling initiatives where you'll forecast potential stream dynamics due to rainfall with this data and utility data lakes. So you could build out reports to monitor stream flooding and put alerts in place to alert folks when levels are too high. So again, overall, there's a lot of possibilities with Utility Data Lake. We're really excited about this product and what it's going to unlock for utilities that we don't even know it's going to unlock yet. And so that's all I had. And again, apologies for going over time, but again, my name is Gray. I'm on the Sensus software product management team. If you have any questions or want to reach out, please feel free to reach out via my email there.
Well, thank you, Gray. We definitely appreciate it, and we had a few minutes where we were, between everybody, we were having some technical issues, so a few minutes isn't gonna kill us. So there were no questions in the chat, but I did have one for you, just one that we get asked all the time, so I figured it might be a good platform for you to answer. Regarding the smart gateway, I have one of the top questions we get is, are there set products that Sensus has to communicate with that? So let's say you want pressure, let's say you want to know if a gate is open or closed, all these different things you can connect to that. Are there set products from Sensus that are available, or is it really truly just connect to whatever you want, or maybe both?
I'll say both. So we have preferred vendors where we've partnered with folks to sell pressure sensors and monitors that connect to our smart gateways. But really, I think the capabilities can be endless. There's 2 ports to connect to, and really, I think we can try to connect really anything. Anyways, we have our water product management team also that we can connect folks to get more into that.
Okay, good. We've been telling people to write that as well, so it's always good to check in.
Please join us for the next Johnson Controls Blue Water webinar on Wednesday, May 17th at 11 a.m. Eastern, 8 a.m. Pacific time. You've probably heard the term smart cities used frequently over the past years, but does anybody really know what that term exactly means? We'll have a distinguished Internet of Things or IoT devices and applications. More importantly, our expert panelists will provide you with case studies of technologies that are available now, and they'll demonstrate how the community is benefiting from being a smart city. Our friends from Senate will be joining us on the May webinar. You can register for the webinar by using the link that you see on the slide, by capturing the QR code on the slide with your smartphone, or just send us an email at bluewater@jci.com and we'll email the registration link right to you. Special thank you to Devan Shields from Sunrise Engineering and Greg Anderson of Xylem. Craig would like to wish all of you who are from Texas a happy San Jacinto Day on Friday.
San Jacinto Day, yes.
San Jacinto Day, there you go. And we want to
Get some
remind
good
you,
barbecue.
Craig loves his barbecue. Please invite your friends and colleagues to attend the Blue Water webinars, and please submit topics that you would like for us to cover in future webinars. We want to know what's important to you and your utility, and you can contact us at bluewater@jci.com. So thank you for attending the Johnson Controls Blue Water webinar today. We look forward to seeing you again on May 17th for our special webinar on what is a smart city and how your community can benefit from becoming one. See you then.
Thank you.
Thank you.